Hey, this is going to be commentary for chapter 41 of my book Metadimensional, which you can find on Kindle or listen to for free as an audiobook on Google Play, and links are in the description. So, chapter 41 is called Virtual Neurons, and it's kind of a nice closure, and that's point of consistency to this theory that is unexpected, and in the previous. When the commentary for the previous chapter, I said that if you're going to model experience according to what this theory assumes, where you have the experiential component is choosing its the objective substrate it reflects on, its body space. This is what choice is, changing between what seem like the perception of different universes. And when you cannot discern the laws of nature from the context of nature, because you don't know what parts of the objective substrate produce the elements in nature, and what of them produce the dimensions of nature. For you, they're all the same. So if you have the capacity to change the objective substrate, it includes changing both the laws of nature and the context of nature. And if you try to model that into a computer language, then your computer program would just crash and burn, because there are some computations that don't work if you can't preserve any semantics, and you can't preserve any semantics according to this theory. So if you want and because this is so easy to make the choices, then you have to have like a different model. And well, now if you want to make sure that no matter what function will continue, then it becomes like pretty clear that what you want is that the thing that this virtual sentience would process, the atoms, the thing that you cannot go lower than that would be functions. Then you always have functions. I mean, execution of functions. But what is a function? So for this you need to know something about mathematics or computer science, but in general, what you need for a function, for the simplest function there is, you have to have a source, a value from which you start, a value from which you end, and you have to have the function will say, if you take this, then you get to that. So you have one piece of information, the source, one piece of information, the target, and one piece of information that's connecting them. These are three independent pieces of information. And the way to describe three independent pieces of information is 3 dimensions. So if you want to have an information state that is resilient to any choice that experience could make, that the virtual sentience would make, that the virtualization of experience would make, you'd have to have that the atoms are functions. And to have atoms that are functions, you need to have a 3-dimensional space. Not in terms of visually 3-dimensional. I mean, 3 pieces of information, independent pieces of information at each coordinate. So happens that this is also the way to describe a 3-dimensional space, which is useful. But it's from a different. I'm not trying to say that a virtual sentience would have to think about 3-dimensional forms or 3-dimensional spatial forms, but it will need to be operating in a 3-dimensional space for it to be able to not crash and burn. So you get back to 3-dimensionality, but now. You get back to 3-dimensionality, which was one of my arguments why to even assume that that experience is fundamental, because you need to go back to the second chapter and the third chapter, and you understand that. But then comes you get another bonus realization. Like, why do we have neural networks in our brains? Now you would say, like, what do you mean? Why? So think about this. We have our digestive system, we have our lungs, we have our eyes, we have, all of them are great mechanical feats. Like we can, the thing when we try to reproduce this using technology with no biological anything, we're in a jam. It's really hard. We haven't been able to do that. However, we have already artificial intelligence, which mimics the kind of stuff that we do in our brain, and it's becoming smarter than any human day by day. And we did that in, I don't know, less than 100 years. So how come evolution was so good at creating our eye, and so lousy at creating our brain? And you see, like, our evolution used the neural networks, like neurons. Computers don't use neurons. Computers use memory bits, like binary bits, and processors, and yeah, they span a lot of spatial size, but we don't know what is the objective substrate of the brain. It could be like analogous to what we have in the biggest supercomputer we have today, or server farms or whatever. But it still cannot do the same thing. So you have to ask yourself, like, why a neural network? Why not SVM, support vector machines, which is another way of reaching the same goal? And there are other machine learning algorithms. And why use neurons and not use binary computation and all that? So when if you go into think about this, you are processing, for virtual sentience, you are processing everything in a three-dimensional space. Now, suppose you want in this organization, in this setup, to have machine learning capacities like we have in our brain and like artificial intelligence has. Then you'd want to somehow implement machine learning algorithms, artificial intelligence algorithms. And now you could then say that inside this three-dimensional space, you'd create a virtual computer, and that virtual computer would run a simulation of let's say of a neural network using matrices and all this kind of, the way we do it in computers. But what for? If you can build things three-dimensionally, then you can just as well just create a virtual neural network inside that virtual space and save yourself the trouble of having to worry about a computer that you don't need. So actually, if you want to have a computer inside that virtual space, which does the same kind of stuff that we do in artificial intelligence, then you want to have virtual neurons. Like instead of them operating virtualized on top of another computer, just have the virtual neurons do the machine learning stuff. So this answers another question, which is like, why do we have neural networks in our brain? Why not have an SVM machine? Why not have a binary machine? It's simply the most optimal implementation of machine learning, insofar as you're going to try to put it as part of the same space that your virtual sentient is supposed to be able to manipulate. And this way, when you have that, then you can have intentionality. You can have the virtual will change the computer, change the virtual neurons, because it is one of the, it's just a function on function on function. It's just like cascading functions. It's just cascading relations or cascading forms. Form and function are equivalent. They are all they're all relations between between things. So everything. So once you go through all this understanding of this virtual sentience architecture, you realize how it corroborates your assumptions by making it clear that only the natural solution is a good solution.